days is really allowing the water moisture to evaporate, allowing that to equilibrate. Whereas if you just heat that up at full speed in a furnace, as the water vaporizes, is probably what's causing your debonding. So if you allow that to evaporate for 4 days first, I'm guessing that's why you then don't observe debonding when you do the annealing. Yeah. So with this, you should be able to get a reasonably good bond strength doing an in situ anneal. Like I say, if you've got it under vacuum and you do the heating under vacuum, any moisture or water vapor or hydrogen or whatever has a chance to be pumped out. So in theory, it won't. You may get some voids, but in theory, it won't debond your cavities. Maybe it will, maybe it won't. I don't know. I can speculate, but I can't tell you for sure. You'd have to try it. Any other bonding questions? I'm sure probably quite a few, but a lot of bonding questions I can't answer. But it's just a matter of try it and see. So, I mean, every application is always going to be like the first time it's been tried. So, it's just try it and see. It's the nature of research, I guess. Where are we? 4:15. Right. I would like to show you wafer clamp setup before we finish for the day, if I may. So,
wafer clamp setup, you mean for 3-inch wafers as well?
I don't have the necessary wafer clamp to do 3-inch clamping, but what I want to demonstrate to you is how we set up the height of this nose and the spring force.
Okay.
So they're both fairly important. If you have too much spring force, you're either going to smash the wafer or bow it, or if you have too little spring force, when you close the lid, it's just going to drop off. So it's quite important to have it set up. It's the kind of thing that you're going to set it up once, set and forget kind of thing. But you need to know how to set it up. So again, we have to remove the rad ring. It's fairly annoying, this ring. It is permanently in the way.
Is it the last thing you were showing for today?
Sorry?
Is it the last thing you're showing for today?
Yeah, I guess so.
Okay.
Yeah.
Because I watched it on the video. I still need to do my homework. So I was
Okay.
nice meeting you today.
You too. No worries.
Alright, bye.
Bye. Okay. Always the first job before we can do anything on the upper pattern is remove the ring. Right, so the height is fairly easy to set up. We simply measure the edge of the platen there, move the gauge onto the nose, and then we can use this thumb screw to adjust the height.
Should be the same height
As
as the platen, or
no, it should be above the platen, so but below the surface of the wafer. So in my case, I had 500 micron wafer, so I want 400 micron above the platen, which is 100 microns below the wafer surface.
and in theoretical, like what's maximum thickness I have? Like, is this have like some weight it can
We use
have?
up to 2 millimeter wafers.
It'd be fine, absolutely fine.
So this is just
I've held a wafer. I've held a 10 millimeter chunk of glass on there before, and it works fine. So the maximum we can raise this to is pretty high. 5.3 millimeters. We can raise that to.
so it's just pushing sideways, right? It's just pushing to those pins.
Yeah, it's what it does is it's pushing against these things. There is a knife edge on the edge of that, so the edge of the wafer has a kind of a C-shaped profile, and the knife edge, in theory, is going to hit the C, or it's going to be slightly above it, so the wafer will be tucked underneath the knife edge.
So if it was like just
Flat edge wafer. We've had trouble. We've had trouble with those before. We have had trouble with flat edge wafers.
They have flat edge.
Do they?
There's no bezel.
We'll give it a try. Hopefully it'll work. But maybe we can just like increase the spring force or something a bit. We'll find a way of doing it. Okay, so have the height roughly set up to 0.4 because I have 0.5 mil wafers. It's quite sensitive. Anyway, there we go. Close enough. Then, any idea where the spring balance is, Carl?
Which?
Spring balance?
Oh,
Yeah, the.
I'll look out here.
Thanks. Oh no, it's here. It's got it. Right. I'm going to use my alignment demo wafer to show you how to do this. So if I just sit the wafer on the platen there without clamping it. Currently the nose is underneath the wafer. So this is a bit crude, but it works. Hook that around there. Hold the wafer against the screws gently. Give this a pull. And I'm measuring the force that it's requiring to pull the wafer out from, to pull the nose out from underneath the wafer. It should be between 300 and 400 grams on this scale. So that was about 340. I've already set that up yesterday. To adjust it, we simply turn this screw pillar here. As
so this is true for every thickness or?
Yes, every thickness. If you've got thicker wafers, I guess you could probably have a slightly higher spring force and it wouldn't matter. The problem with thin wafers, if you have too high of a forces, you'll bend it, you'll bow it, or potentially even break it if you have way too much force. Hopefully, I think this spring isn't powerful enough to apply so much force that it breaks the wafer. But I've never tried to push it to destruction kind of thing.
We have like from 250 to.
No, we have 100 microns.
You have 100 microns. You might struggle to clamp that. You need to contact AML. I mean, at the moment.
Probably, with that, if it didn't have any features, we can just put it.
Yes, yeah. Yeah, if you don't have any features, it's fine. You don't need to clamp it then. If you did want to clamp a 100 micron wafer, I think we'd struggle to accommodate that, to be honest. Because
Put 100 micron over there and then directly here.
these screws, I think the smallest, the thinnest head that we have is 0.15, which means that the thinnest we can potentially clamp is a 200 micron wafer. 100 micron, ring AML and ask. They might be able to make some screws specially if you wanted to clamp it. But I also think you'd have even with 300 grams, you'd have a good chance of bending that wafer. It'd be very difficult to clamp. It's just
like 1 millimeter to 100 micron. Can we just put the 100 micron at that side and then 1 millimeter
Yeah.
here?
Yeah, that'd be fine.
We don't do 100 to 100. We do 100 to 1 millimeter.
That's fine. So yeah, I would clamp the 1 millimeter on there. You have another set of screws. These ones are 0.4 millimeters. You have a set that's 0.6 millimeters. So use the 0.6 millimeter one for your 1 mil, wafer. Yeah. So
Talking about the quality, right?
yeah. So if you wind this spring pillar anti-clockwise, it will increase the spring force. If you wind it clockwise, it will decrease the spring force. So you just keep repeating this procedure until you get it right. At the moment, it's already right, so I don't really want to adjust it. But it's the sort of thing you set it up once and then you don't really have to worry about it again. So if you change the platens over, or you change to a different wafer clamp, use a chip jig one for example, or you change to a 3-inch one, you don't have a 3-inch one yet, but you might order one by the sounds of it, then you may have to set the spring, do this setup, but you do need to do it once and then that's it. Every time I do an anodic bond, I like to kind of use my tweezers and just check here. Check that you can feel a step between the wafer and the nose. If it feels flat, it's a good chance that the bonding voltage will short. So, yeah, the screws are less critical because you can't adjust the height of the screws. They are the height that they are. So, but yeah, you can check them as well. That's what I do also. Yeah, you can feel the step there. Here we go. Yeah, the glass should be above the screw. So there should be a step of about 100 microns. The larger you can make that step, generally, the better. But if you make it too large, you won't clamp the wafer and it will drop when you close the lid. So again, it's a trade-off. Okay. Any questions on the wafer clamp?
So is this one, this is for the height, this is for the load, right? That's it.
Yep. Removing it, I'll show you removing it actually. You will need to remove it if you need to do any maintenance, like change a heater bulb, for example, if a heater bulb blows. That probably will happen at some point during the machine's lifetime. Just get this out of the way. Yeah, just these two screws to take it out. You've got a couple of spares there as well, by the way. Yeah, I was going to say, that's a good idea. At least have a pot or something to keep them all in. Then lift it up from the rear and just kind of tease it out. Try not to kind of pull back on this mechanism because you can risk bending these spring strips. We don't want to bend those if we can help it. Then, so the way the actuator works, this pin sits inside this recess, and then that, when you turn the handle, that just pulls this back. This small pin here, yeah. So reinstallation, just the opposite, go in at an angle, try and jiggle that under the platen. This big washer here has to sit on the inner face of this bracket, and the spring post sits between it, and that just drops into place there.
So after removing this, you just remove everything to replace the bulb.
See what, sorry?
To replace the bulb.
Yeah, I'll show you all that tomorrow. It's quite an involved process. Yeah, you have to remove the platen, remove this. Removing this requires you to unrelease the leveling mechanism. Then you can take that out. Then you have to detach the heater from this support ring. So it's quite a big strip down job. The lower one is easier. All you have to do is undo these 3 screws and the thermocouple, take the platen away, and then you can access the bulbs directly. The upper one is quite involved, so I'll show you all that tomorrow.
So what happens if one of these bulbs is broken and we didn't replace it? So
It won't work. Heater won't work.
It won't work?
They're in series. They're in series. So yeah, you'll know if one of them blows, you'll know because this light will be on, it will say it's heating and the temperature will be falling. Right, so I'll just put those screws back in. Heater bulbs, you can probably, in the US, you can probably find the right thing locally. You can probably buy them here.
Granger.
Yeah. Failing that, you can always order them for AML. Although you can probably get them cheaper if you buy them locally.
Leave the plasma ring out for tomorrow.
Yeah, I think so. Yeah. Because tomorrow I need to take that platen assembly out and show you how to change heater bulbs, and then that's just going to be in the way again if I reinstall it. So all I have to do is take it out again first thing tomorrow morning. So that's probably quite a good place to call it quits for the day. I'm going to leave him on here. Yeah. Okay, good. Right, I'm going to shut the machine down. I'm just going to back up all the log files now that I've completed the 2 bonding. Ah. I didn't create a new log file, so I need to amend the name of this.
So it's done manually, right? Otherwise, it will keep adding to the same log file, right?
Yes. So after I finished the anodic bond, I forgot to shut down. I forgot to end the process and then start a new process to do the direct bond. So it's basically done both of those bonds in one log file.
Oh, so it will not remove the old log files.
It won't overwrite it, it just keeps writing to the same log file until you end the run. The only way it overwrites a log file is if you start a new run and then give it the same title as an old run. Then it will say, this log file name already exists, do you want to replace it? And it will ask you twice. It asks you once for the data log and once for the event log. So if you made a mistake and you want to start it again, then you overwrite it, obviously. If you haven't, then it gives you a warning. Yeah, I was just going to back up these. I finished all my testing and bonding now, so I can back up all these log files and Dropbox them home.
So what are these 3 lights for? Red.
Red is a fault state. Green, it will flash green when you start up the program. So this is flashing green there, indicating that it's kind of awaiting some selection from you. And when you start the process, that will turn to a solid yellow light, which kind of means it's in use at the moment. And then in the event that anything goes wrong, the red light will be illuminated. And in theory, the buzzer will also sound, but I've disconnected the buzzer because it annoys the hell out of me. So, yeah, there we go. Reconnect it. In theory, it should never go off because nothing's going to go wrong. Sorry?
If someone didn't know like what this sound, it would be very scary.
I can show you what it sounds like. It's not pleasant. Yeah, it's annoying.